The exponential growth of the usage of the word penguin from 1930 to 1990.
Our data is the exponential growth of the usage of the word penguin from 1930 to 1990. This data, collected from Google Ngram Viewer, shows how the usage of the word penguin changed over time. We chose this data because we were interested in penguins, and initially we wanted to do penguin populations, but when we couldn't find reliable data on that, we chose this data instead. The independent variable is the number of years since 1930. The dependent variable is the percent of words in books published that are penguin. In order to find my equation, I plugged the points into the general formula y equals a times b to the x. Then I divided both sides by b to the 10th to solve for a. Next, I plugged the value I got for a into the other equation and I solved for b. Finally, I used the value of b to solve for a. Then I took a and b and put them into y equals a times b to the x to get my final equation.
My function was formed using the same process Lindsay explained, but the approximate points 20, 10 times 10 to the negative fifth and 50, 7 times 10 to the negative fourth. My graph was much less steep than Lindsay's graph. My graph is very close to hitting most of the points aside from 40, 4 times 10 to the negative fourth. Therefore, similar to our regression function.
Using a similar process as the rest of my group, I found the equation y equals 3.78 times 10 to the negative fifth times 1.059 to the x. Using point 0, 3.78 times 10 to the negative fifth and 50, 6.74 times 10 to the negative fourth. This was very accurate at estimating y values at x equals 0, 10, 40, and 50. It overestimated for x equals 20 and 30. It is quite similar to the other graphs in terms of steepness and accuracy.
This is my graph, which contains the 2 points 10, 5.8 times 10 to the negative 5, and 50, 6.7 times 10 to the negative 4. The exponential equation containing both of these points went by the formula y equals 3.2 times 10 to the fifth times 1.0632 to the x. Using this equation, I determined that in 2154, 100% of words in books would be the word penguin, and in 1990, 125 hundred-thousandths% of words in books will be penguin. Compared to the other graphs, the formula was very similar. However, my exponential function had larger a and b values than the others, yet yielding a very similar exponential line that went through a majority of the points.
We used our equations to try to predict when all words contained in books would be penguin. On average, we found that this will happen in the year 2180, just 1 year earlier than our full regression model predicted. Unfortunately, these predictions are meaningless as it is unlikely for the usage of the word penguin to continue growing like it has. Our data points of interest include our first and minimum point in 1930, which is 0, 3.78 times 10 to the negative fifth, and our last and maximum point in 1980, which is 50, 6.74 times 10 to the negative fourth. We had no notable outliers in our data. This data is exponential because the add multiple property is observable in it.
A reasonable domain for this data is 0 to the end of time because it's years after 1930, so until the world ends, people were more than probable right about penguins. A reasonable range for this data would be less than 1% and more than 5 times 10 to the negative fifth.